Hey there, so today we're going to learn a third way to add fractions, and I think you're going to like it. You can use this method when you're adding any fractions. If the denominators are related or the denominators are not related, this method will still work. However, sometimes you end up with larger numbers in your fractions than you would doing it one of the other ways. Okay, so that's why I always wait till the end to teach you this one. So the quick multiply, I'll show you on just a simple problem like 1/2 plus, 2/3. Okay, so number one, I don't have to think about the denominators at all. I can do this on any addition problem. Okay, step number two, multiply your denominators and write it as your denominator answer. Okay, so I'm going to write equals. I'm going to draw my fraction bar, and then I'm going to put my denominator on the bottom, which would be 2 times 3. 2 times 3 is 6. All right, I've already got half of my answer. Next, switch colors a little bit. Next, you always start with your top first numerator and you do a diagonal multiply. They call this a cross multiply. Okay, so 1 times 3, I'm multiplying on the diagonal. 1 times 3 is 3. Okay, and then I'm going to multiply on my other diagonal, starting up here, and that's 2 times 2, which is 4. Okay, so then my answer is going to be, I'm going to take this number, the 3, and this number, the 4. I'm going to add those together. 3 plus 4, that makes 7. So let me go back over here and write a 7. And then if I wanted to write an even better answer, I would say, well, that's improper. So if I can pull 6 pieces out of the 7, that would make a whole. And after I pull 6 pieces out of the 7, I would have 1 left over of those 6ths. Okay, so my answer is 7/6 or 1 1/6. Okay, I'm going to go ahead and, let's see, clear, and I'm going to do this one more time using mixed numbers. Okay, so this time I'm going to do 1 3/4 plus 2 1/6. Okay, so I like to break up my wholes and my fractions, so I'm just going to right off the bat take my 1 and my 2. 1 plus 2 makes 3. So now I don't have to worry about these guys for the rest of the problem. Okay, I'm going to go ahead and rewrite over here so I have a clearer space. I have 3/4 plus 1/6 now. Actually, I'm going to erase that because it's too close to my answer part. I don't want to be confused. Okay, I'm going to do it up here. 3/4 plus 1/6. Okay, so step number 1, yes, I can use this because I'm adding 2 fractions. Step number 2, multiply denominators. Okay, that would be the 4 times the 6, okay, and that makes 24. All right, step 3, cross multiply. I'm always going to start here and go down. 3 times 6, I know my facts, that's 18. Go to my next fraction and cross multiply. 1 times 4 is 4. Okay, step 4, add numerators from step 3. So those are my 18 and my 4. Okay, 18 plus 4 is 22. So I could write my answer as 3 and 22 24ths. I could also see that that could be reduced by a multiple of 2. So I could divide both parts of this fraction. The 3 would stay the same, but my 22 could become an 11, and my 24 divided by 2 would become a 12. And it's just nice to write your fractions in the lowest numbers that you can, the lowest digits. It's just easier to understand the relationship that way. Okay, so let me go on. Clear. All right. Okay. So here's our work for today. They give us an apple cake recipe. 1 2/3 cups apple juice, 1 1/4 cups water, 1 1/3 cups oats. I'm just reading this recipe right here. And 1 1/2 cups of flour. And then I'll come over and read the step in. How would you calculate the total amount of juice and water in this apple cake recipe? Okay, so juice and water. Okay, so again, we have these two people, Hugo and Charlotte, and they've solved the problem 2 different ways. Hugo changed the amounts to improper fractions to add. And then Charlotte left hers as mixed numbers to add. So let's start on Hugo's first. We can do a quick multiply because we're adding 2 fractions, right? So first operation is that I'm going to multiply. That didn't come out where I wanted it, but I'm going to multiply my denominators. 3 times 4 is 12. So I know that's half of my answer. I'm going to cross multiply. I always start at the top of the first one and go down. So that's a 5 times 4. That's 20. You can go the other way. 5 times 3, and that's 15. And then remember, my operation here is that I'm adding. So I'm going to add my numerators, 20 plus 15, and I get 35 twelfths. So we'll go ahead and look at Charlotte's way now. Charlotte would do her wholes and her fractions separately. So with Charlotte, I'm going to add the 1 whole plus the 1 whole to get 2. And then I'm going to cross those out. And my problem is now 2/3 plus 1/4. Sorry, my handwriting is getting pretty bad. Okay. All right, so first step, multiply denominators, 3 times 4, and that makes 12. Next step, cross multiply, so 2 times 4 is 8, 1 times 3 is 3. Add those numerators, 8 plus 3 is 11. So in this problem, I get 2 and 11 twelfths. We'll have to see if those are actually the same answer. So I've got 35 here, and I can take out 12 to have 23. So I know I have at least 1 whole. And if I subtracted 12 again, oops. Stop. Okay. Okay, if I'm subtracting 12 again, 23 minus 12, I'm left with 11. Okay, so I was able to subtract 12 twice, so that makes 2 wholes. Let me switch my color so it's not all looking the same. 2 wholes, and I had 11 left over after I subtracted, and my denominator is still 12. So yes, we get the same answer whether we use improper fractions or whether we add the wholes and fractions separately. Okay, get rid of that. Okay, so calculate each total. All right, so I could use impropers or I could add wholes and fractions separately. You know me by now, I like to do the wholes and the fractions separately. So I know that I'm going to have a 1 plus 2 as part of my answer. So right away I know, whoops, no. Oh darn, it's not going to let me use the, okay, I'm going to stop. I'll stop playing with it, sorry. It's not going to let me use the ABC to type. However, you guys, on your slide, you will be able to double click on the ABC fraction and you'll be able to put in your numbers. I can't because I'm presenting. That's why it's not allowing me. But I know that the A is probably going to be 3 because that's 1 plus 2. All right, so that leaves me with this problem, 1/4 plus 1/3. If I do a quick multiply, I would do 4 times 3 to get 12. And then I would cross multiply. 1 times 3 is 3. 1 times 4 is 4. And then I would add those 3 and 4 to get 7. So I'd combine that with my 3. So my answer is 3 and 7/12. Okay. On my next one, I don't want to write, there we go. My next one, how about I do this one using impropers? Okay, so if I change the 2 and 1/3 to an improper, that means that I have 2 wholes. Each of those wholes has 3 pieces. So 2 sets of 3 is 6 plus 1 more. So that makes 7, I'll write it up here, 7/3. Okay, I'm going to change my other one to an improper. This has 3 wholes, 5 in each hole. So 3 groups of 5 is 15, plus the 2 is 17. And then I still have fifths, is what I'm talking about. So my problem becomes 7/3 plus 17/5. Okay, I can do a quick multiply because we've learned today that whenever you're adding fractions, you can do a quick multiply. And let's see, my denominator is going to be 3 times 5, so 15. There's part of my answer. I'm going to cross multiply then. 7 times 5 is 35. And 17 times 3, whoops, is 52? 52? Wait a minute. Let's check that because I've been known to make a mistake before. Can you believe it? Oh, look at that. I did make a mistake. It's 51. All right, 51. Okay, so 35 plus 51 is my next part, and I'm not going to do that in my head again, just in case I Make another little mistake, so I'll write it out. Oopsies. That's an 8, but it won't let me write 8. So 86. So you'll notice that my answer here in this problem has pretty large numbers, 86 and 15, whereas my answer over here has some smaller numbers, 3, 7, 12. And the drawback of what I've done here on B for my answer is improper. The numerator is larger than the denominator. So I'll have to do some subtracting or dividing in order to get a mixed number that's equal to that, so I can report my answer. So I'm going to do that. Let's see, will it let me write over here? Yes, it will. Okay, so I'm going to write on this side. I hope you can see it on the video. But I'm going to do 86, and I'm going to subtract 15 as many times as I can. I probably should have started up higher. I think it'll take a few. So I'll start 86 up here. And I'm minusing 15 as many times as I can. Okay, this is just another way to divide. 6 minus 5 is 1. 8 minus 1 is 7. Okay, so look, I have one whole there. I can subtract 15 again. I have 2 wholes now. Subtract again. I have 3 wholes. Subtract again. Now I have 4 wholes. Subtract again. Oops, computer. 26 minus 15. Again, I hope you guys can see this. I'm writing on the sides. I'm afraid you're not going to be able to see it, but I'm just subtracting 15 as many times as I can. Okay, and so let's see how many times I subtracted. 1, 2, 3, 4, 5. So that means that 86 divided by 15 is going to give me 5 wholes. And then I had 11 left over after I subtracted all my 15. So that's my numerator. And then I'm just going to keep the same denominator, the 15. Okay, so my answer, come on, 15. So my best answer to B would be 5 and 11/15. That's equivalent to 86/15. Those are the same amount. They're just written differently with different digits, but they have the same relationship, so they are the same value. I know they don't look like they have the same relationship, but they do. That's what our fraction is, a relationship between the numerator and the denominator. Okay, so I am hoping that you guys can take a look at, here we go. Oh, geez. Number 2, calculate. It says using mixed numbers. You don't have to necessarily add your wholes and fractions separately. If you wanted to do impropers and then reduce at the end, you can. I just feel like that sometimes leads to extra steps at the end, but you do what makes sense to you. And oops. Okay, and then we've got another slide here. Number 3, 2 questions. And then I've included this step ahead that says calculate the total number of hours that were worked, then write the answer as a mixed number. Okay, so that means that you will be adding these numbers, right? The total number of hours that were worked on Kathy's timesheet. Okay. All right, I can't wait to see what you guys come up with. And we will talk tomorrow. Bye.